As winter rains flow through California's streams, salmon gather offshore. They've spent most of their short lives in the ocean. Drawn by natural forces, they return to the rivers that gave them birth. Eventually, the flood of fresh water from the river's mouths trips a primeval instinct to fight their way upstream against powerful currents, leap waterfalls, and battle their way through rapids to spawn. A new urgency comes over them as they swim up their native stream to begin the return home. Over a century ago, streams along the west coast of North America were teeming with thousands of salmon. Slowly, over the years, rapid urban development, pollution, and lack of care have depleted the stocks. We've become used to what we don't see. Creek restoration is one approach to reverse this trend to help save the wild salmon from extinction. Along the Central California coast, Cal Poly State University is involved in one such venture at the Swanton Pacific Ranch, located in northern Santa Cruz County. The overall goal of the project is to restore Quesarilla Creek that was channelized around the 1890s for agricultural purposes, by removing the stream from the drainage ditch and reestablishing it to a natural meandering channel. Walter Mark, the director of Swanton Ranch, is the facilitator of the stream restoration work that bisects the property.
Quesarilla Creek is one of the tributaries of Scotts Creek. Scotts Creek is the creek right behind us here. Scotts Creek is the furthest south stream that has all three cohorts of coho salmon still breeding in it as wild fish. And in the summer when Quesarilla dried up, we had Fish and Game come out and remove the fish and relocate them into Scotts Creek. And that year we got about 150 steelhead and about 5 coho out of a little pool in Quesarilla. So out of this little drainage ditch through a field, we got as many coho as they found in about 50 sites that they surveyed along Scotts Creek.
The project is being carried out by the Cal Poly staff and students. Brian Dietrich with the Department Natural Resources Management of Cal Poly State University is the project manager for the project.
Some of the most high intensity or highest intensity rainfalls in California are found right here in Santa Cruz County, and specifically right around Swanton Pacific Ranch. That has led to a number of problems in Quesarilla Creek. First of all, the mountains in the Santa Cruz mountain range are rapidly uplifting. We combine that with high intensity rains, you experience rapid runoff, high volumes of runoff, and also large amounts of sediment is produced through erosional processes.
Fisheries biologist and researcher Sean Hayes with the National Marine Fisheries Service explains how the project will assist in fish migration.
97-98 El Nino was a year class where the coho almost completely failed to spawn just because the winter storms were so fast and furious they weren't able to get in and find sort of low flow quality habitat for them. Everything was too fast and furious during that year, and as a result that year class is almost extinct.
The main purpose of the project is to provide refuge for coho and steelhead trout. The drainage ditch will be replaced with a meandering stream with beneficial features like clean gravel, spawning pools, and large woody debris.
The Fish and Game grant that we got initially was just for the lower Quesarilla Creek portion. So let me start by kind of describing that. And what that was to do was to take the drainage ditch portion of Quesarilla Creek that had been a straightened channel, excavated channel through the fields, and move that over into what we believe was the old configuration of the channel by looking at old air photos and seeing vegetation patterns and just indications of different soil types that we can see in some of the old air photos.
In 1994, Swanton Pacific Ranch was donated to Cal Poly by alumni Al Smith. Al expressed a desire to see greater utilization of this unique property by providing an environment in which to live and learn. To promote this philosophy, the ranch provides a living laboratory for Cal Poly students. Jason Pearson is a graduate student who is learning by doing, by being involved in the engineering plans and the actual installation of the project.
I came aboard when Brian introduced the idea of me being a grad student and doing the design and implementation for this project. When we came out here to map the actual meandering channel in the field, I took that drawing and a number of points along the curve, wherever there was like a break in the curve, and put that back into our surveying software, created a point file, which is what's on this map. So we're going to shoot those points, then from those field stakes, then I can come out with the excavator and excavate out into the channel from that stake. I can measure the distance, the width of the channel, the depth of the channel at that stake.
Large pieces of wood in a stream are an important part of the ecosystem and are critical to the survival of trout and salmon. Logs and redwood stumps are installed in the stream to divert water to create pools and provide cover. The transplanted redwood stumps establish themselves much more quickly than seedlings, thus accelerating the development of large trees needed for shade as well as erosion control.
I'm standing here beside one of our redwood stumps that was transplanted into this project area. As you can see, it's sprouted now, and that's what we were hoping for. About 80% of them have sprouted, and we used these to try to get redwoods established here faster than we could by transplanting seedlings. And they'll do a couple of things for us. One, this is along the edge of the floodplain, and it creates a hard nick point along the edge of the floodplain so that the stream won't get outside of our floodplain. The other area that we planted them was right along the streams, particularly on outside edges of meander bends, in the hopes that they'll help control the stream geometry and keep the stream in the channel that was designed for it. They'll also provide us with shade canopy on the stream, which will shade the water and keep the water temperature cooler, which is an important critical part of the water quality in salmonid habitat. Okay, these are some of the redwood logs that we'll use as in-stream structure also. These are from our other property down by Watsonville, we call Valencia Creek, and these will be put in for log weirs for making the vertical rise up to the culvert for Swanton Road crossing, because we've got to gain quite a bit in elevation, and we'll make a series of step pools for the fish to be able to migrate through using log structures and rock structures.
Cal Poly also received funding to incorporate artificial logs into their project design through a McIntyre Stennis grant for research purposes. This study includes comparisons between using natural and simulated aqua logs. The artificial log is constructed from concrete and visibly indistinguishable from a natural log.
Part of the research component of our project is to compare the use of the cement aqua logs by benthic macroinvertebrates to the use of natural wood logs in the stream. And the smooth ones will be buried basically as footers or hold down material to hold other structure in place, and the rough ones will be used like a regular log, so you'd see them on the surface.
U.S. Fish and Wildlife Service is one federal agency available to assist in creek restoration projects. Jeff Rose, a civil engineer with the Pacific region of the Fish and Wildlife Service, is actively involved with Cal Poly in the design and construction of Caesarea Creek project.
We're here today to look at two different types of structures that we are putting in this newly designed and constructed stream channel, the cross vein and the J-hook. These are both two structures that can be built from either rock or they can be built from logs.
These engineered structures, constructed with boulders and logs, break up the flow velocities and thus the erosive power of the water. This in turn creates scour pools for spawning and rearing habitat for fish.
This meander realignment is approximately 1,600 feet in total length, as opposed to the original straightened stream section, which was about 900 feet in length. So by adding all these meanders through here, we've added stream length to the system, which will result in more pool and riffle habitat for the salmonids. We'll be putting in 10 J-hook structures down here in the lower floodplain area, basically one for each bend in the stream.
In the situation of this bend here, we are going to put a J-hook rock vein starting off of this inside bend, we have the elevation where the top rock will sit. We'll want to come off of that 0 degree line parallel to the bank at 20 degrees, and we want to slope down at 3 to 7%. That's critical in that when the energy of the flow is directed towards this structure and it intersects these top rocks that are going to be right along the grade line of the stake that I'm holding, it's going to bend those flows in, take the pressure off the bank, and will protect a section of the bank that is equivalent to somewhere in the neighborhood of 2.5 times the actual vein length. You can see it as soon as water hits that structure that's designed and built properly. It'll actually quiet that water and raise the stage to take the pressure off that bank up and downstream. So those dimensions are the most critical in building these structures. Just using these dirt clods, if we had this footer rock buried below the surface and we set our top rock on, it's going to be set back, and this will serve as almost a splash apron to prevent undermining. If you don't put these in, we'll scour out a hole underneath this rock and it'll just simply roll into the hole. So these footer rocks are a critical part of the design of this structure. And as we take this grade down into the thoweg of the channel, we'll actually hook the J around in a downstream, leaving gaps between the top rocks of about 1.5 feet between the top rocks as strictly a habitat feature. It creates some nice little converging areas for trout like to concentrate in these areas for feeding lanes. There's a lot of nice oxygenation that happens in these areas. But that is the only purpose of the J-hook. It's a habitat feature.
So this here is a rock J-hook. We're about halfway through building it. What you're looking at now is the footer rocks that run at grade with the stream. This structure is a little more difficult to build than the log J-hooks, I would say, mainly because of course rocks are all different sizes, and it's almost like fitting together a little puzzle, trying to line up the rocks and get them nice and level, get them at the right angle, whereas the log J-hooks, you have a nice uniform straight log. You can just kind of just build your trench to the right angle and slope, and you just set it in there and then set another log on.
While culverts provide drainage under our roads, they often block annual migration of fish. A culvert in Upper Caesarea Creek was removed to enhance fish passage to the upper reaches of the watershed, crucial to migrating salmon.
Underneath Swanton Road, we have an existing culvert that is a significant problem to the success of this entire project. It's an undersized concrete round culvert. I believe it's 30-inch in diameter.
That now has about 18-inch to 36-inch drop out of the outlet depending upon time of year, and acts as a migration barrier to upstream movement of salmonids. Replace that with a 14-foot wide arch culvert under the road. And then in order to get to that level, we're going to create a series of step pools between the Lower Ag Crossing and the Swanton Road crossing using a combination of redwood logs, cement logs, and rock weirs. And all those will be part of the ongoing study then for looking at the impacts on habitat.
The Caesarea Creek watershed has heavy winter rains that impact the area every year. This hydraulic information is taken into consideration when calculating the size of the culvert.
The other problem was the alignment of that culvert as it came underneath Swanton Road, pretty much at 90 degrees to the road. Caesarea Creek took a 90-degree bend, and so during high flows we had discharge just shooting right into the bank that was putting some of the structures that were right on the other side of the culvert in jeopardy.
The County of Santa Cruz Department of Public Works collaborated with Cal Poly to replace the culvert in the upper portion of the project where Swanton Road crosses over Quesaria Creek. With the assistance from U.S. Fish and Wildlife Service and grant funding from American Rivers Restoration Program, this important fish crossing improvement became a reality. Jeff designed the bottomless arch culvert with a natural stream bottom to improve fish passage.
Part of the project to ensure the success for the upstream migration of the salmonids is we want to replace that culvert underneath the county road with a bottomless arch structure that will be set on precast concrete footings. This is a structure that, keep in mind, replacing a 30-inch circular area with a 15-foot span of the channel, 6.5 foot high. So we've increased the actual capacity of that existing culvert by a factor of 8. Now that's a corrugated metal plate structure that is shipped in sections and then actually bolted across in the arch. So you just work from one end of your precast concrete footings that are set, the other end backfill according to specifications and strict compaction requirements, and then resurface the road and pave it over the top to complete the project.
Darwin Christensen, the business development engineer with SureSpan, assisted with the on-site construction of the culvert.
This is a structural plate arch to be used for stream crossing to get traffic over a fish-bearing stream. And it creates a natural stream bottom through the bottom of the arch rather than a metal bottom or a concrete bottom, which gives the fish an opportunity to rest as they're going through when they can find pools in the stream bed and under the arch. This arch is being placed on precast concrete footings. An alternative to the precast concrete footings would be to cast the footings in place. However, that requires quite a bit of time in forming and placing the concrete and then waiting for the concrete to cure. One benefit to using precast, and that is that you don't run the risk of having fresh concrete get into the water during the pouring process. The concrete is already cured, so you don't have the chemicals getting diluted into the water and becoming a toxin for the fish.
The biggest threat to salmon today is the loss and degradation of habitat. One of the most important roles native plants contribute is providing shade for the streams and rivers in order to keep the water cool.
So what we want to do then is try to speed up the process of recovery, and that's what as we're implementing, that's what we're really talking about. In addition to the habitat, in-stream habitat things, we're also working on the riparian community that provides a lot of the important habitat features in terms of feed, in terms of wildlife benefits for other species, and also just some additional plant diversity that doesn't exist in Quesaria Creek right now, because once it enters the eucalyptus grove, there's basically nothing but eucalyptus, and then it entered an ag field and there was nothing because of the agricultural practices. So the benefits from the vegetation, like what you see behind me here, weren't there. And actually what we would like Quesaria to look like is a lot more like this. A lot of native plant species with a multi-storied canopy, including some herbaceous and woody things at lower level, but those are all important aspects to providing the salmonid habitat. You need the overstory to provide the deep shade to keep the water cool during the summer months, and then you need some of the lower overhanging type vegetation to provide the shade cover for the fish's ability to hide in some of the habitat features that are in the stream. So it takes a combination of in-stream features and the riparian community to really establish the kind of restoration that we're looking for.
Riparian plants dramatically affect insects, fish, birds, and mammal populations by providing food sources. Without plants, the entire structure of the biological food web is impacted and diminishes the ability of the stream ecosystem to survive.
It's restoring the ecosystem, the local ecosystem of Quesaria Creek. And in fact, rather than calling it restoration, it might be more appropriately termed a renaturalization of Quesaria Creek.
Native species of plants were collected and propagated from seedlings found or grown from Scotts Creek watershed to maintain the gene pool of the local riparian communities. Allison Aquino is the graduate student who is in charge of collecting, growing, and planting the native species.
Our main plan of attack is to get the native grass seed in there as quickly as possible so it'll sprout, which hopefully will keep out some of the non-native species, and then as a preliminary effort, and then when we get the native plants in there, hopefully they'll come up and be able to dominate enough to keep the non-natives out. So this is just one example of one of the species of the bunch grasses that we have down in the lower project site. We're going to have some people come out next week, and one of the things we're going to do is dig these up and just instantly transplant them to the E-type channel, the lowermost part of the Caceria Creek project, where the area is designed to be dominated by grasses.
Whether it is in the stream or near it, the vegetation is an extremely important part of healthy fish habitat. Riparian plants not only stabilize the channel banks and prevent erosion, they improve spawning habitat and water quality conditions. Jim West is the biological advisor assisting Cal Poly in the revegetation effort.
Taking Caceria Creek and making it a restorative process, not taking into consideration what's going on adjacent to it, is a mistake. So fortunately here, by having more plant forms that bring in more birds, bring in more insects, the spillover is that the agricultural crops being raised here also are the beneficiaries. So this becomes really an integrated, a very holistic project. It's something in the process of becoming. It's not cut and dry, it's not a cookie cutter effect, but it's really an evolving concept. And the information derived from this particular project, the ramifications go far beyond merely watershed restoration. They go about how you deal with sensitive habitats, how do you enhance an existing habitat, how do you remove the non-native influences or allow the native influences a chance to reconquer those areas that human intervention has actually created a non-level playing field.
Especially now that all of our ag fields have been fenced, this becomes could become a real important migration corridor for species that are on the other side of our ag fields to come down to Scotts Creek. In the summer, a lot of them use that for a water source because most of the intermittent sources are dried up in the hills, so they've got to come down to Scotts Creek itself. So Caceria Creek could become an important wildlife corridor for other species, and we kind of have that hope.
California once hosted some of the biggest salmon runs in the world. Being part of so many ecosystems, however, has its price. Salmon are vulnerable to ecological disruption at any point in their journey from gravel bed to ocean and back again. Tom Bolich, the Director of Public Works, who is involved in many culvert replacement projects in the county, knows how important the condition of our streams and rivers are for the recovery of the endangered fish.
The County of Santa Cruz Department of Public Works, with grant support from U.S. Fish and Wildlife and in conjunction with Cal Poly University and grant support from American Rivers, recently completed a project on Swanton Road at Caceria Creek. We are pleased to be involved in the replacement of the Caceria Creek culvert in what promises to be a very successful restoration program that we hope we can use as an example for future public works projects.
We still have much to learn about stream restoration. The creation of Caceria Creek will provide a learning center from which useful information will be generated for future stream restoration projects.
One last crucial aspect of this project is that it has provided educational opportunities for a number of graduate students who have developed their master's theses in the research work going on and design work going on for this project. It has also involved a number of student interns here at Swanton Pacific Ranch, and it is undoubtedly going to serve as a demonstration project for many different types of classes, both at Cal Poly, at UC Santa Cruz, for decades to come.
I've definitely learned how to move through the entire design process of a project and make something implementable from the design. And it's one thing to design something on paper and on a computer and then they actually turn around and do it in the field. It's a totally different thing, and it's an extremely valuable experience doing both.
We plan to use it as a demonstration area, bringing groups out to show them what can be done in ag fields and in ag settings for creek restoration projects. We use it a lot for some of our case study courses that we teach at Cal Poly, for a real on-the-ground case that the students can come and pick apart and crawl through and get in the nettles and get in the poison oak and everything out here.
Through stream restoration projects like these, research and monitoring programs will continually improve our knowledge and give us guidance for future recovery efforts. With time, it may possibly reverse the past adverse impacts and eventually restore historic migratory fish runs. By restoring Quesirilla Creek, the spawning fish will be able to seek refuge at a crucial point in their migration. And for the first time in over 100 years, they will swim up a restored creek to complete the return home.